Determine all real solutions to the equation, da 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 da. Okay, I assume this won't factor nicely, and so we need the rational zero theorem, or the rational root theorem. And it says, if you're going to try out some numbers for this equation, the numbers to try are the factors of the last number over the factors of the first number. So we have to try plus or minus 1 and 3, those are the factors of minus 3, over plus or minus 1 and 2. Those are the factors of the first coefficient. So our list of candidates is plus or minus 1, plus or minus 1 over 2, plus or minus 3 over 1, and plus or minus 3 over 2. Now, we'd basically just have to try these one after the other at this stage until we find one that works. The good news is they often cook these questions so that 1 or negative 1 works, because they don't want you to spend all day plugging fractions into a polynomial and evaluating. That's tedious, and we know that you can do it. So I'll try 1 and negative 1 with my fingers crossed. If x equals 1, we get 2 times 1 minus 1 times 1 minus 1 times 1 minus 3 equals 0. Nope. That's negative 3 equals 0, so that one did not work out. How about negative 1? Now we get 2 times negative 1 cubed minus negative 1 squared minus negative 1 minus 3 equals 0. How does that work out? 2 times negative 1 is negative 2 minus negative 1 squared, so that's minus 1 plus 1 minus 3 equals 0. Rats, also no good. How about 3? I'm avoiding doing the fractions because they scare me. So if x is 3, we get 2 times 3 cubed minus 3 squared minus 3 minus 3 equals 0. That's 54 minus 9 minus, no, not going to work. How about negative 3? Please let it not be a fraction. If we do negative 3, we get 2 times negative 3 cubed minus negative 3 squared. This isn't going to work either. Minus 54 minus 9. No, we're never going to make it back up to 0 after all that. Okay, not good. It's got to be one of the fractions. So I'll erase this and keep on going. I'm going to do 1/2 in decimal form because it's quicker for me that way. So I'm going to say x is 1/2 and work it as 0.5. 2 times 0.125, that's 0.5 cubed, minus 0.5 squared minus 0.5 minus 3 equals 0. That's 0.25 minus 0.25 minus 0.5 minus 3 is not 0. Rats. If x is minus 0.5, 2 times minus 0.5 squared is minus 0.125. And then we have minus 0.25. And then we have minus negative 0.5 minus 3. How about this one? Minus 0.25 minus another 0.25 plus 0.5 minus 3 equals 0. Incredible. That didn't work either. This is a test of adversity. Okay, so the only hope left is that it's either 3 over 2, which is 1.5, or it's negative 3 over 2. So let's see if one of these works out for us. If x is 1.5, we get 2 times 1.5 cubed. That's 3.375. I better check that. The last thing I need right now is to make a calculation mistake. 1.5 to the 3, yeah, 3.375. So 3.375 minus 1.5 squared is 2.25 minus 1.5 minus 3 equals 0. Okay, so this is 6.75 minus 2.25 minus 1.5 minus 3 equals 0. This might do it. 6.75 minus 2.25 is 4.5, minus 1.5 is 3, minus 3 is 0. We finally got it. So, as you can see, and I deliberately bashed through all this to show you that the rational zero theorem can be a bit of a grind, and you have to be persistent and careful and check your work to make sure that you finally get, that you don't miss it when you finally do trip over the right answer. So, 1.5, or positive 3 over 2, is one of our solutions. And now the question is, are there any others? Now that we've got a grip on this polynomial, we'll see if we can tear any more pieces off of it. If 3 over 2 is a root, that means x minus 3 over 2 is a factor. But I don't want to play with minus 3 over 2. I'm going to multiply this whole thing by its common denominator and turn it into 2x minus 3. That's easier for me to work with. So the question is, if this polynomial is divisible by 2x minus 3, then what's the rest of it? Long division can tell us. 2x cubed minus x squared minus x minus 3 is divided by 2x minus 3. How does that go? 2x goes into 2x cubed, x squared times. X squared times 2x is 2x cubed. X squared times minus 3 is minus 3x squared. Now we subtract. The x cubeds kill each other. Minus x squared minus negative 3x squared is like minus x squared plus 3x squared. So we get 2x squared from that. And now we start again. 2x goes into 2x squared, x times. X times 2x is 2x squared. X times minus 3 is minus 3x. The x squareds cancel out. Minus x plus 3x is 2x. And 2x goes into 2x once. 1 times 2x minus 3. We know what's going to happen here. No remainder, so hooray, we win. That tells us we divided out 2x minus 3. That was our divisor here. And what was left of the polynomial after that was x squared plus x plus 1. That's a quadratic, which means we have a lot of ways to attack it, and that's good. You can try to factor that, and I'll tell you right now that you won't get anywhere. It doesn't have any integer factors, or I don't believe it even has rational factors. So our last chance to attack this thing is with the quadratic formula, which can crack any quadratic if it actually has roots. So our last shot at solutions is to say that x can be minus b. I'll write it out with my last little bits of space. Plus or minus root b squared minus 4ac all over 2a. The good news is a, b, and c are all 1 for this quadratic, so this won't be terribly complicated. Minus 1 plus or minus root 1 squared minus 4 times 1 times 1 all over 2 times 1. Do you see why we can stop now? This section in here is called the discriminant, and if you look at what's going on inside there, we're getting 1 minus 4, which is the square root of negative 3, which we can't do at the moment. We don't know how to take the square roots of negative numbers. In fact, we often tell you it can't be done. And so this root does not exist. which means this doesn't exist, which means there are no solutions to this second piece. The only solution that this thing has is the one that I ground out by trial and error, 3 over 2. It's the only valid solution. We tried hard to get other solutions, and this is the way you do it. You divide out any factor that you can find and then attack what's left. But in this case, it didn't get us anywhere. There's only one real solution, and it's 3 over 2, or 1.5.